Hi everybody. We're going to do one more example on piecewise functions in section 2.4, and then we're going to move on to 2.5, which is solving absolute value equations. So on your test, you're going to have to evaluate a piecewise function. So we're going to practice one of those. And the function they gave us is g of x equals x plus 5 if x is less than or equal to 3. Which is right here, or g of x equals 2x minus 1 if x is greater than 3 or less than or equal to 7. So the first thing they're going to ask us is what is the domain of g? And if we look at our inequalities here, our domain of g is going to be defined by our two inequalities that we have here. Our first one says x can be less than or equal to 3. And then our second one says that x can be greater than 3, but it has to be less than or equal to 7. So because of this, we're going to say our domain is going to be all real numbers where x is less than or equal to 7, because it looks like 7 is the maximum value allowed, but then it can be anything lower than 7. So now when we go to evaluate, when we do g of -1, our first one, we have to go up here to decide which equation to use. We have to figure out where -1 fits in our two inequalities. Because it's -1, that's going to put it here where x is less than or equal to 3. So the problem that I'm going to do is the x plus 5. So I would do -1 plus 5, and my answer would be 4. Next, we're going to evaluate g of 0. And that one still fits into the inequality up here, where x is less than or equal to 3. So I'm going to do the same equation. I'm going to do 0 plus 5. And that gives me 5 for my answer. Now we're going to do g of 3. And this one's a little tricky because 3 is in both inequalities. But if I look, my first one says x is less than or equal to 3. So it's still going to be that first equation. And we're going to do 3 plus 5 this time. And we get 8. All right, we're going to move on. And now we're going to look at g of 7. And when I look for my inequality here, 7 fits into this bottom inequality. So I'm going to use the 2x minus 1 for my equation. So it's going to be 2 times 7 minus 1. And that will give me 14 minus 1, and it equals 13. Our last one they ask us to evaluate will be g of 8. And if you notice in the top part, we listed our domain, and it was all real numbers where x was less than or equal to 7. Since 8 is greater than 7, and it's not listed on either of these two inequalities, it doesn't meet the requirements, then the answer would be no solution. The number does not fit into the given domain. All right, and that will be it for piecewise functions for now. And now we're going to look at absolute value equations, and we are going to solve absolute value equations and absolute value inequalities in section 2.5. So don't forget your absolute value function would be f of x equals the absolute value of x. And remember, our graph for our absolute value function is the V shape. So here's our graph right here. And the domain is all real numbers. The range will be y has to be greater than or equal to 0. And x will always be increasing when x is greater than 0, but decreasing when x is less than 0. When we solve absolute value equations or inequalities, we're always going to have to, or most of the time, have to solve two equations. Because when we look at the absolute value of x equals 5, okay, I can have two solutions to that this equation. Because if I put -5 in my absolute value symbols, remember the definition of absolute value is the distance a number is from 0, and -5 is 5 spaces away from 0, and distance is always positive, so it equals 5. But then also the absolute value of the number 5, positive 5, is 5 spaces away from 0 as well. So we have two solutions. X can be -5 or +5. So when we solve absolute value equations, we have to account for getting a negative answer in the absolute value symbols or a positive answer. So we'll always write two equations unless our absolute value is equal to 0. And we'll take a look at that in a minute. All right, when we solve our absolute value equations, there's a couple things we have to remember. K, which is your answer right here, has to be a positive number. Okay, because remember, we can't have, the absolute value of, I'll get it to right here. So the absolute value of a number cannot be a negative answer. You can never have the absolute value of something equal a negative value. When you solve, there's a couple steps that you have to do. You must isolate the absolute value before you can apply the definition. So before you can split it, you have to isolate your absolute value. So if there's anything outside the absolute value symbols, either added or subtracted or multiplied to it, you have to move those to the other side first. Absolute values can never equal a negative number. So again, you can't have that negative number. They can't be equal to a negative number or the answer is no solution. And you always want to check your solutions in the original equation because sometimes you can get extraneous solutions, which means solutions that you get when you solve it, but don't actually work within the absolute value symbols. All right, so here's our first absolute value equation that we are going to solve. And we have 2x plus 5 in absolute value symbols is equal to 2. So remember, what we have to do is we have to split our equation into two. We have to say that we have our equation 2x plus 5 and make it equal to -2, because remember, the inside can be equal to a negative number, because when you take the absolute value, it becomes positive, or 2x plus 5 equals +2. So you have to create those two equations, and you'll have a question on your test where you'll have to do this as well. So first thing we're going to do is, now that we've created these two equations without the absolute value symbols, we're going to solve them. So I'll subtract 5 from both sides on the first one, and I get 2x is equal to -7 divided by 2. So x equals -7 over 2. And then here I will subtract 5, and I get 2x is equal to -3 divided by 2, and we get x equals -3/2. And then remember, you do want to check for extraneous solutions. You want to make sure that your solutions work in the inequality. So when I go to check, I'll make red here. So let's check. I'll do, for the first one, we'll do the absolute value of 2 times -7 over 2 plus 5. And we want to make sure that that equals 2. So remember here, when we're multiplying, those 2's cancel out, so we end up with the absolute value of -7 plus 5. We want to see if that equals 2. And -7 plus 5 will leave us with the absolute value of -2, which is equal to 2. So that solution does work. Let's do the same thing with our positive solution that we got. Let's check it. So we will do 2 times -3 over 2. Plus 5, and we want to make sure that's equal to 2. So again, the 2's will cancel, so we end up with the absolute value of -3 plus +5. And inside that absolute value symbols, we get 2, which does equal 2. So both solutions here check. All right, we're going to practice solving some more absolute value equations. And here are some that are going to have some different situations with them. Our first one, we have the absolute value of 3x plus 12 equals 0. And for this one, any absolute value equation, we want to set it equal to the positive and negative solution. But when we have 0, there is no negative 0. So we only have one equation to solve here. And that equation would be our 3x plus 12 is equal to 0, since there's no negative. And we'll go ahead and solve it by subtracting 12 on both sides. So I end up with 3x equals negative 12, divide by 3. So we get x equals negative 4. And then we are going to go back and just check it. And if we do 3 times negative 4 plus 12 in our absolute value symbols, that gives us negative 12 plus 12. And that would equal 0. So that does check out. So that one's good. Okay, for our next one, we are actually going to create two equations here. The first thing we're going to do is, remember, one of our steps is to isolate our absolute value equation. So right now I have the absolute value of 5x minus 4 minus 7 equals 15. I have to isolate my absolute value. So before I split it, I am going to add 7 to both sides. And when I do that, I end up with the absolute value of 5x minus 4 equals, and if we add 15 plus 7, we get 22. Okay. Now I can go ahead and split my equation because I've isolated my absolute value. There's nothing else on the same side with it. And we'll do 5x minus 4 equals negative 22, and 5x minus 4 equals positive 22. And solve our equation. So I will add 4 to both sides, and I get 5x equals negative 18, divide by 5, so we get x equals negative 18 fifths. And then we're going to add 4 to both sides for the next one. And I get 5x equals 26, divide by 5, and x equals 26 over 5. All right, I want you guys to take a second and check both solutions. And then once you do that, I think you'll see that both of them actually do work. All right, let's take a look at our last equation here. Make a little space. And again, we have to isolate the absolute value. So the first thing I'm going to do is subtract my 5 from both sides so I can isolate my absolute value. And I end up with 4x plus 8 is equal to 3 minus 5 will give me a negative 2. All right, there's something that we said at the beginning of this section. When we're solving absolute value equations, we cannot have absolute values that equal a negative number because absolute value talks about the distance a number is from 0. If our answer, once we isolate the absolute value equation, is a negative number, then we don't solve this equation. Our answer is no solution. And it would really be like no real solution because we could look at complex numbers here, but we're not going to worry about that today. So our answer is no solution because you cannot have an absolute value equation equal to negative 2. All right, the last type of equation that we're going to solve today is an absolute value equation where you have two absolute values equal to each other. And we are going to solve this similar to the ones we just did. We're going to have a positive and a negative answer. This time, though, it's going to be an expression. So we're going to start off, and we'll just keep our 2x minus 9 as is, and we're going to make it equal to 8 minus 3x, so that would be our positive equation. And then we're also going to do, I'll change to red, another equation. We're going to do 2x minus 9, so we're going to keep that as it is, but this time we're going to make it equal to the opposite of 8 minus 3x. So that's where our negative comes in. All right, so to solve the first one, let's combine our x's. So I'm going to add 3x to both sides. And I'll end up with 5x minus 9 equals 8. Add 9 to both sides. So I get 5x equals 17 divided by 5. So x is going to equal 17 fifths. And then for the second one, let's distribute our negative. So we have 2x minus 9 equals negative 8 plus 3x. So now, so I can keep my signs as positive as I can, I'm going to subtract 2x from both sides. So I end up with negative 9 equals negative 8 plus x. Add 8 to both sides. And we end up with negative 1 equals x. So those are our two solutions. And again, you do want to check them by plugging them into your equation. So let's see, I'm kind of running out of room here. Let me erase. I'm going to erase the first one. I'm going to erase this, but our answer was 17 fifths. Let me just make a little bit of room. And you can always, rewind the video if you need to see the problem again. All right, that's good enough. Okay, so when I check it, our answer was 17 fifths. So we're going to do 2 times 17 fifths minus 9 and make sure that that is equal to 8 minus 3 times 17 fifths. Okay, so when we multiply here, 2 times 17 will give me 34 over 5 minus 9. And then here we will have 8 minus 8 minus 51 over 5. Oops, and that's an absolute value. Okay, so let's do the math. And this is one where I would definitely say you are free to, break out a calculator to help you. And when I use my calculator to do the calculations, I end up with, for the first one, the absolute value of negative 11 over 5 is equal to the absolute value of negative 11 over 5. And the absolute value of both of those would be 11 over 5 is equal to 11 over 5. So it does check for the first one. Let's try the second one. I'll see if I can shove it in here. Let's see here. We have the absolute value of 2 times negative 1 minus 9, and that should be equal to the absolute value of 8 minus 3 times negative 1. So when we do the math here, for the first one, 2 times negative 1 will give me negative 2 minus 9. And that's going to be equal to the absolute value of 8 plus 3. So negative 2 minus 9 is going to be that plus a negative. So we get negative 11 is equal to the absolute value of 11. And if you look, the absolute value of negative 11 is the same as the absolute value of 11. So we have 11 equals 11, and the solution does work out. Okay, we're going to solve absolute value inequalities next. That's the last part of the section. And when we solve an absolute value inequality, here we have to pay attention to our symbol. If your absolute value sign or equation, or the absolute value part right here, is equal is less than or equal to k, then you're actually going to set up your equation like a compound inequality. But if your absolute value expression is greater than the solution, or k, you're going to set it up as a two inequality equation. So you'll have that or between the two. And we'll take a look at both types of those. Okay, so here we have an absolute value where 2x minus 5 is less than or equal to 6. Because our absolute value symbol is less than, that means when I go to set it up, I'm going to use a compound inequality. So that means I'm going to do negative 6 is less than or equal to 2x minus 5, which is less than or equal to positive 6. And I will go through and solve this compound inequality just like we did in class the other day. First, I'll add 5 to all three parts of the inequality, and I'll end up with negative 1 is less than or equal to 2x, because our 5's cancel out, which is less than or equal to 11. Then we'll divide by 2, and we'll do that to all three sides. So we end up with negative 1/2 is less than or equal to x, which is less than or equal to 11 over 2. And they do want us to write our solution set in interval notation. So remember here, when x is in the middle, that means our interval notation, because it's less than or equal to, will be a bracket, negative 1/2, comma, and then 11 over 2 with another bracket. And that will be our interval notation. Okay, so now we're going to solve another inequality, and here this time again it is less than or equal to 3. So when we solve it, it will be another compound inequality, and we'll have both 3 and negative 3. So our negative 3 will go first, is less than or equal to 4 minus 5x, which is less than or equal to 3. And remember, with your compound inequalities, when you write them, your signs are always facing in the same direction. So if they're not, something's wrong there. So that can help you with getting those signs down. And they're always, because we're always going to start here with our regular one of the less than, they're always going to point towards, think of it like towards the left. All right, to solve this equation, let's subtract 4 from all three parts. And so we'll end up with negative 7 is less than or equal to negative 5x, which is less than or equal to negative 1. And then we'll divide all three parts by negative 5. So we end up with positive 7/5, because two negatives make a positive, is less than or equal to x, which is less than or equal to positive 1/5. And then we're going to write our answer in interval notation. So when we write it, we are going to, remember, you want to kind of write it like you read it from left to right. And 7/5 is greater than 1/5, so we're going to put our 1/5 here, and then our 7/5, and then put our brackets. And that's it. Okay, now we're going to solve two inequalities. This time, inequalities that have greater than here. So remember, now we're going to write them as an or statement, or we're going to write two separate inequality statements. Now the first one, again, you want to isolate that absolute value before you do any rewriting of the problem. So we are going to subtract 5 from both sides to start with. And I'll be left with the absolute value of x minus 9 is greater than 1. And now, when I go to write my problem, we're going to say x minus 9 is greater than 1, or x minus 9, and because we're switching to the negative, we're going to do is less than negative 1. So when you write the negative answer, flip that sign around. And then we'll just solve them like the two inequalities, two regular inequalities. So we'll add 9 to both sides. and we get x is greater than 10, or here we'll add 9, and it will be x is less than 8. So x is greater than 10 or x is less than 8. Now, they are going to ask you to write this in interval notation. So for this one, I'm going to start with the x is less than 8. That would be, your interval notation, remember, would be negative infinity to positive 8, both with parentheses. Then, because it's or, it's a union, we'll put the u between it. And then x is greater than 10. So we're going to have, let me erase that part real quick. We're going to have 10, comma, positive infinity with parentheses around it. And that would be our interval notation for that one. Okay, let's look at this last one here. And this one is also a greater than. So when I set it up to solve it, I'm going to have two equations. I'm going to have 5x plus 6 is greater than or equal to 12, or 5x plus 6 is less than or equal to negative 12. And again, when you write that negative one, flip that sign. Then we'll solve it by subtracting 6 from both sides. So we get 5x is greater than or equal to 6 divided by 5. And we get x is greater than or equal to 6 over 5. And then here we'll subtract 6 from both sides. So we have 5x is less than or equal to negative 18 divided by 5. And we get x is less than or equal to negative 18 fifths. So again, when we write it in interval notation, this is going to be the lower of the two. So I'm going to use a parentheses, negative infinity, comma, negative 18 fifths, and we'll put a bracket around it because it's included. Or means the u between the two, and then we'll have a bracket with our 6 fifths, comma, positive infinity. And that is it for solving inequalities.